So if you will think back in time before Christmas, back in the fall when we visited Canyon Lake Gorge. Do y'all remember going there? Okay, so we're going to kind of do a backtrack on that lesson and kind of refresh our brains. I know that the year is winding down, and if y'all are like me, I've got everything planned out, and I'm working on next year right now. And so I thought this would be a time when we can refresh ourselves a little bit about some things that we've learned, and then you'll have an opportunity to make some notes on how you can implement these things into your classroom next year. Because I have a list of this, and I've made notes about how I need to edit what I'm doing going forward, and so maybe this will be a little refresher so that you can remember what we did and then have some time to figure out how you want to use it. And if you weren't on those trips, yay, because we have this new knowledge that you can acquire today, so you can see where we've been and maybe use some things for yourself. So let's keep going. We're going to look at Canyon Lake Gorge first. So first, in July of 2002, y'all remember that there was this huge flood and the lake filled up and it went over the spillway. And when it did, it washed away everything in its path.
Lauren, do you need to turn all the lights off for certain pictures?
So we can,
Yeah, it's hard to see.
This is a physics room. I have no control over removing light, bulbs anyway. So like I do in our
no
room.
plugs. I
Or
like
do you want the lights off? Y'all in the back call it.
I'm good.
lights off. He's like, we're students right now. Lights off.
Lights off.
Come on.
Stay away.
Okay.
I'll squirt you with water guns. Okay, so this water washed over the spillway. There's a picture of it from somebody's house or something as it came over the spillway. And if you remember on our trip, we walked across here and it was exciting, and we looked at how they tried to fortify the dam fortify the spillway with putting. Well, didn't they like drill down into the concrete and
Yes, in
okay,
between,
yeah,
yeah.
that was awesome. So here's what it left behind. So it washed away all of the dirt, all of the soil, all of the trees, the vegetation, and it exposed this beautiful geology that we were able to walk through. This stuff has been covered, and so this is the first time it's been seen. And so there was a lot of things that were exposed there that it was like a geologist's happy dream there. It's beautiful. So, all right. So one of the things that it exposed is a fault line called the Hidden Valley Fault. You remember hearing about the Hidden Valley Fault? It's part, you've heard of the Balcones Fault Zone that runs northeast, kind of sort of along 35, and this is part of that. So what it did, I'm sorry, that is not very bright, is it? You okay? The lights on? All right. So we're going to look at the geology, so this will make a little bit more sense, but this is where the Glen Rose Formation slipped down on the Gulf of Mexico side during the Tertiary period, which followed the Cretaceous period. Now, if you remember from our talks, the Cretaceous that's when this area was covered by a little shallow sea. We're on the verge. That's when all of these limestone rocks were created. So we're going to look at EarthViewer. Y'all can get out your apps, get out your iPads, and open up the app EarthViewer.
Oh, I forgot to tell you new people, we buy you iPads.
Have you ever get that conversion for the scopes that we ordered for the new iPads and scopes? They never got it for the newer iPads. To the little tire one. Okay. We've just been using
either borrowing them, so tear it down.
Yeah, I know.
Two more sections.
my children. That's why. It's not.
Well,
Rescue process only have like less than 2 Yeah.
Okay, guys, do y'all have your apps open?
Yes.
You got it open. Okay, so Earth Viewer, if you keep the time at present time, there's a scale on the left-hand side. And I think if you're online, you can look up Earth Viewer on your computer too. It's not just an app. But you can manipulate time on the left-hand side. And as you manipulate time, the continents move according to where they were during that time on the Earth. So as you go back in time, the continents move. You can put on there, you can view like cities so that you can track where Houston is for time. You can track where, let's see what it shows on North America. Los Angeles, Calgary, Chicago, Toronto, New York, Washington, D.C. You can zoom in, you can zoom out, and you can manipulate what you're seeing. So first, play with that time scale a little bit. Go backwards and forwards in time, just to make sure you know how that works. I want you to know, think back to what you know about continental drift and what you know about how continents move. And I want you to know the shapes of the continents and how they fit together as you go back through time, particularly whenever you go back to about 250 million years ago. Now, if you look back on your time scale, you can see that the Cretaceous period, it's on the left-hand side, it's a green bar. The Cretaceous goes between, let's see, 140 million years ago to, I don't know, 75 million years ago. Back when we were teens. So put your time scale within the Cretaceous, more towards the beginning of the Cretaceous, please. And then manipulate the Earth so that you see the United States during the Cretaceous. And you can zoom in a little bit if you want to, because we're going to be focusing on what is happening to Texas during the Cretaceous. Okay, so whenever we visited the dinosaur, what was the dinosaur tracks? Yeah, you know the museum.
The Heritage Museum.
The Heritage Museum. The woman that gave our little tour made me giggle and cringe a little bit when she talked profusely about the crustacean period. It is not the crustacean period. It's the Cretaceous period. But there are lots of crustaceans. There were crustaceans during the Cretaceous. Yes. We saw seashells down by the seashore. Okay, so look at the bottom of your iPad, and once you have your scale down at the bottom of the Cretaceous, you can hit play down at the bottom, and you can. It's really quick. You may have to zoom out a little bit, but you can watch what happens to Texas during this Cretaceous period.
Oh, doing this to the fire.
You can also, that's a little fast for me,
Yeah.
but slowly move your scale to watch what happens to Texas. And what do you notice about 100 million years ago? What is Texas experiencing? particularly Central Texas. It's covered with water. Is it an ocean? Is it like just a lake? What is it? Yes, it's more like a shallow sea. So it's not an ocean, it is a shallow sea. So all of this land here that we're on was covered with a shallow sea during this period. So keep that in mind and know that when fossils are formed, they don't form on land. They're covered by burial of sediments that preserve either the bones or the shells or the footprints, or what we saw is footprints. So that's when these things are formed and preserved.
Laura, could we stop for a minute and ask who's maybe having technical difficulty?
Who is having technical difficulties?
Could we ask what the technical difficulty is? We have some technical experts in here, but it does not include me. Mostly my students.
It's the Wi-Fi they're saying.
Huh?
She's saying it's the Wi-Fi and I can't fix that. Unless we have a rep.
There's a guest.
I walked around it.
Oh, I don't have it.
Oh my God, yeah,
Laura, if every table has at least one iPad that is working, everyone can look on it, that's good. So let's not worry about trying to get more than one because it's gonna hold us back.
Okay, so look at a working iPad. You know the app now, and you can go home and download it on some internet.
We don't have connection.
Ready? Okay, so look at this. On your iPad, one of the things that you hear about in geological time is the tertiary period. It's not there. On your iPad, it is subdivided into the Paleogene and Neogene. So just be aware that it's subdivided into two different periods on your iPad, but you're going to read about it and hear about it at that time that follows the Cretaceous, called the Tertiary. All right, this is not all right, so we know that this area is covered with a shallow sea. So what do you expect, whenever y'all go to the ocean or whenever you visit shallow seas, whenever you visit shallow seas, what kind of environment do you expect to see?
Well, Gal just did a ton of seaweed and shells.
Okay, lots of crustaceans?
Yeah.
Shells, okay. What? Tidal pools,
A lot of cephalopods.
Okay, right. Anything else?
Coastal
Yeah.
Lots of algae,
Okay.
I guess, around there.
Yes. So all of these things that you're mentioning now, we can infer that that's what was present in these shallow seas then. And this is called a law of uniformitarianism. And all it says is that whatever we observe now is what we think happened then, so that we can apply what we experience now to the situations that we believe caused geology to be the way it is.
Could we stack some human bodies and get some idea about Unitarianism? So who would be above or below you?
Oh, that's a different.
Oh, I'm sorry, you're right.
That's a different one.
Oh, but see what I was trying to think of, the concrete, how can we use some concrete examples to teach a pretty abstract idea?
Yeah, and I think that's a great idea, and that would be great fun.
For the next one.
Yes.
But my body would be on bond, so.
So all this means is that we can look at what is now to make predictions about what was and what caused the earth to look like it is today. All right, so your iPad and your VGA connector, y'all that have received iPads and you received your VGA connectors with your smart scopes, y'all, am I ringing the bell? Okay, let's brainstorm on how we can use these in our classroom. We've got the Earth Viewer app, so what can we do with Earth Viewer? How can you use this app not only to look at what Texas looked like as a shallow sea 100 million years ago? How can we use this in our classrooms? What TEKS can we use it for? So brainstorming session, I'm going to paper to brainstorm on.
Oh, yeah.
Crush cells at the bottom of the
Okay, guys.
Yeah, I'm at Congress Elementary.
So what are some applications that we could use with this app in the classroom? We've talked about geologic time. So what grades include teaching about geologic time? Fifth grade?
Sixth grade.
Let's start with fifth grade. Fifth grade, what do you teach in fifth grade? What does the teach say?
Apparently, TEK 5.7 is exploited processes that led to the formation of sedimentary rocks and fossil fuels.
Okay, and how could you use this app to demonstrate that?
Well, I could, between bringing in the fossils I found at Dr. Hunt's house, and then some of my students have lots of land as well where they've found fossils and things like that. I'm sure I can make that connection. I'll get a concrete example right there about so that's a, I found this here in Texas and how they decompose, and then show them the change over time just on the screen. Or sometimes I had the moment I can put that one there and let them see it for themselves.
Okay, good. And while we're using this app on our iPads, it's also on the computer. Y'all don't have to, it's not strictly just an app on the iPad. You can get computers and use it on the computers too. So I like what you're talking about, that's showing that these fossils represent saltwater organisms, ocean organisms, yeah. And I mean, we're sitting above land. How can we find a coral or a gastropod or something that doesn't live on land? Why is it here? So I love that connection that you made. Okay, what is another one that I heard 6th grade somewhere? 610C. 610C, okay. And what does 610C say?
Identify major tectonic plates.
Identify major tectonic plates. And how would you use this to identify major tectonic plates?
As a station that can actually see other plates.
Can you speak up? We can't hear you in the back.
You can use this as a station to show students how the plates have moved over time.
Okay, use this as a station to show how the plates have moved over time. And that TEK 16C is very closely related to an 8th grade TEKS, and I can't remember what it is, that talks about the plates. It's not identify the major tectonic plates. It talks about the interactions and the boundaries. So you could use this website, this app, to look at how those boundaries occur and the landforms that occur with those boundaries that are as a result of those boundaries.
8.9B.
8.9B goes nicely with that.
Tectonic plates to the formation of crustal features.
And that's very few words for a whole lot of information. And it's very complicated. And it's really hard to demonstrate that so that students understand it well. And I think that by seeing the earth actually moving, and you're able to move it with your finger and see it happening, that really brings home some of the concrete things that we have done in our classrooms, you know, about pushing Play-Doh together and watching the folded mountains, or using those squeeze boxes that we've used in our classrooms, or creating the divergent boundaries and the mid-ocean ridges that we create. So I think that using something like this, we can make it more real. Yes, go.
So how can we use this in a math class? Okay, I want you to look at it and think about it, and then we're going to have some ideas. So you math teachers, step up.
Should we look at
And play around with it. There's a lot of features on that app that you can look at.
So don't shout it out, just write it down or something, and we'll talk about it when everybody gets a chance to look. Doesn't mean the science people are off the hook.
For the math.
Yes, sir.
my student life I wish I was stretched out as a math. Maybe I'll learn.
What do you guys do for math? If we do something with the other time, that's
Does it have I wish there was
numbers, I'm thinking those are my latitudes, so where are my longitudes? Because I was thinking maybe it's very important, right? It's my axis, but I'm not seeing latitudes.
short answer.
Okay, so place value.
I might get her checked out.
That's not a lot of reading graph, reading data.
Okay, we can put that together and share our ideas. We can finish our sentence and come back together.
If you could finish your sentence and come back together.
Okay, we should be back together as a class with no one talking so that we can all hear each other. I have to tell the new people here, I'm very, very old, and I cannot hear when several side conversations are going on. So I'm more insistent that you be quiet when I need you to be quiet than some of the sweeter people are in here, okay? So the math people had some time to think about how they could use this in math. So raise your hand if you have an idea. Oh, come on, this is really great. Okay, Jim?
If we could use BC as a negative number and 80 as a positive number, then we could do we can extend previous knowledge of sets and subsets of rational numbers, and they can create Venn diagrams out of that, which is 8th grade teach. They can order and compare real numbers, which is 8th grade teach. Also, we're doing the same thing, but on a number line.
Very nice. And Venn diagrams and number lines. Okay. Jen?
There's a little button down there that says charts. You can compare 1 or 2 charts, and there's one that's longevity view that shows what could appear, day length, what could appear to be a constant rate of change. This is 7th grade TEAC.
Okay, constant rate of change.
But you can also compare and then build them into possibly dot plots or something.
Okay, good. Yes, sir?
Yes, we looked at comparing the percentages of oxygen, carbon dioxide from different cities.
Louder.
Oh, percentages. We looked at comparing and contrasting the percentages of oxygen and carbon dioxide. Teach them how to work with percentages.
Yeah, yeah. I was waiting for somebody to say that, because that's the first thing I went to when I
That's the
was
first thing she said.
looking at it.
Oh,
Yeah.
really?
And ordering, we could order those numbers as well.
Good. They can order the numbers. Very nice.
Face value too.
Anyone else? That's this side of the room. Tanya?
Well, I saw that as you move through the periods, then the latitude and longitude changes, so we can track that. Also, the length of day changes, and the distance between, like, it had Toronto and Chicago, so it's the difference between,
A link.
this period to this period.
Linear measure. Yes.
So, no question. I saw the numeric for the longitude, but I wasn't seeing for the latitude.
I
Did you
didn't
see
pay
the
attention to
numbers?
that, I just saw
Okay, because I
one.
was thinking on the coordinate plane as well, and you can make it coordinates to do social studies, math, and science all at once, but I could not find the numbers for latitude, only for the longitude.
Well, we
So
have to let
unless
you play with it a lot.
And also, unless you tell them to assume, if you look at the latitude, it seems like it's going by 15, so you're supposed to pretty much be consistent wherever you're doing the facing, so we're assuming that the latitude is as well. But I don't know, and you can only work at the northern hemisphere for doing 5th grade because you have to stay positive.
You're right, the
You
first
can't.
quadrant.
Mhm.
Yeah. Okay,
So, but
great. So that's this side of the room. So we're over here.
Well, they took all our.
No other ideas over here? Just someone. Timeline?
Well, I was thinking with the rate of change that they could make predictions on where, based on where Los Angeles is now in 100 years or 1,000 years, where is Los Angeles going to be?
Oh, cool. Okay. Nice, nicely done, man. Anybody else? Okay, thank you. So,
Okay, so have you got some ideas on how, yes?
I have a question, I'm not a technology person. I got this stop animation camera. Someone had said you could actually with iPads do stop animation. So I was wondering, is it possible to do stop animation with an iPad? Because if you could, then you could actually do, like, here's this place underwater, and now we're going to raise it up and let some of the water run off and do a stop shot, and they can actually create their own, like, this is oceanic or a sea, and now it, can you do stop animation with an iPad? Or do you have to have
somebody
that?
behind you?
Any
that might be
camera,
able to-
yeah.
Blair?
You could?
There are different apps for it, but I don't know one in particular.
That may be a lunchtime discussion.
Yeah.
Okay, sorry.
Yeah, that's really interesting. That sounds like a really cool thing to use.
Or maybe it's already done.
Yes.
Yeah, don't reinvent the wheel.
Yes, Google it.
Okay, so one thing I want to bring up is, we are constantly aware to beware sloppy language, right? And I know that that's a frustration of mine at work, working with college graduates, that scientists, that use sloppy language and misuse of apostrophes, that our sloppy language leads to misconceptions and misunderstandings. Even, we don't mean it, we know what we're talking about, but if we use the term, say, beach, what do you think of whenever you say a beach? When I say, oh, look at the beach, what do you see in your head? Somebody back here. Sand and sun. Sand and sun. Okay.
Water?
What else?
Yeah, water.
Water coming, waves.
Like gentle waves coming in, surfers, fruity drinks with umbrellas, maybe. Yeah. Next field trip, I think. We're gonna go look at the beach environment. But Did y'all notice whenever we were touring Canyon Gorge, our fabulous guide talked about the beach? This was a beach, this was a beach, this was a beach. Did y'all, I mean, that was the term he used for all of the different environments that we looked at throughout time. It was not a beach. I mean, maybe there was a beach in some areas at some times, but that's not what we looked at. If you look back at your Earth Viewer app 100 million years ago, it was underwater. It was a shallow sea. The entire Central Texas area was not a beach. And that is a big misconception. Please don't use the word beach. Use the word shallow sea, and that shallow sea was rising or falling, so the depth of that shallow sea was changing throughout time, and so the environment changed. So when the environment changed, the species that were present changed as well. That's why we saw, when we looked at the stratigraphy of those rocks at Canyon Lake Gorge, we saw some certain fossils in some areas, and we didn't see any fossils in other areas, because the environment was not conducive to the survival of those species. So it,
Laura.
Yes.
Excuse me. We're using the term because it indicates causation. And oftentimes in science, we don't know, most of the time, we don't know why things happen. We know it happens. We know some characteristics of the phenomena. We try to predict when it happened. Where, when, what, but we don't know why. So typically what we should not say is why something happens, because kids will say, why does this happen or not? And I tell my students this story about when I was in organic chemistry. I had a Chinese organic chemistry teacher from mainland China, and she, when we got to the electron distribution, and, you know, it's beautiful initially, and then it goes crazy. And so we said, Dr. Fan, why does that happen? And she said, I don't know, God made it so. So the idea of trying to explain why things happen in nature is misleading to children and to adults, because we don't know why most of the time. We can make inferences, and this is actually what Laura's doing right now, is making the inferences in many cases based on such and such evidence. So be careful with trying to say why things happen in nature. It's better to say, well, we can infer this because of this evidence, and whenever they're doing their own investigations, that's the same route that they should take. You know, that our conclusion is such and such based on the following evidence. And so,
one other thing that we looked at when we went through is we looked at a layer of limestone that had a very resistant top. And do you remember our guide talked about cyanobacteria? Remember the cyanobacteria? Okay, all that is blue-green algae. I mean, he never said that, and anyway, that's what we know as blue-green algae. So just a note from that. One other thing, we need to look at limestone. All we saw was limestone. So let's look at how limestone is formed. First of all, limestone, all it is the mineral, mainly calcium carbonate. When we did our mineral test, and we were testing minerals several years ago, you got your little bottle with acid in it, and you dropped acid on minerals, what were you looking for? A chemical reaction. So the chemical reaction told you, what did it tell you? If there was a chemical reaction, what did you observe? The bubbles. Okay. And what did the bubbles tell you? Or what was that a test for?
To see if it had carbon in it.
Yes, something was happening. Good. Thank you, Ashley.
Actually, we're looking for evidence. We can't say that was a chemical reaction because we don't have the technology like a university chemist would have. We're looking for evidence, and therefore we can infer there was a chemical reaction. And your TEKS actually say that, evidence of a chemical reaction, not if a chemical reaction occurred. And it goes back to the same sloppy language that we're talking about in, no. And, well, we do that. I mean, we catch each other, the instructors catch each other on that. So, you know, it's what we naturally do, but as teachers, we have to be aware of that, and we have to say, no sloppy language. It cannot be precise, and that's why one of the requirements for this project is that you videotape yourself, because we don't look the same on videotape as we think we look in. Yeah, and there it is. So that's one of the requirements. I don't have to look at it. You know, you have to look at it. You have to be reflective of your own teaching, and the principals will enable you to do the videotaping. But you also will have your iPads. You can do that with your iPads and just look at it yourself.
And it sure does help behavior in the classroom. When there's a video camera in the back, pay attention. So the evidence of that chemical reaction is the creation of a chemical reaction is when a new product is created. And the evidence that you see are those bubbles whenever the acid reacts with the calcium carbonate or calcite. So that acid test is testing for the mineral calcite, calcium carbonate. And calcite is the mineral that makes up predominantly limestone. There's grains of sediments in there too, but mainly it's calcite. Sometimes we'll see dolomite, and calcium and magnesium have the same number of valence electrons and can replace each other. And oftentimes you'll see calcium and magnesium carbonate. And the difference in that is that dolomite with the magnesium is more resistant and it's harder than limestone, so it weathers more slowly. So just,
is that what causes the terracing?
that is exactly what causes the terracing, is the difference in the hardness of, or the resistance to weathering of the different types of limestones. And the dolomite does not react as much to the acid as the calcite does. Okay, so we've heard a whole bunch of words that all mean limestone. I mean, you hear about this and that, and all these different words, and all they mean is limestone. They're just sub-classifications of limestone. So we're gonna look at some of these words that we learned about a couple of years ago, but if you don't use it, you lose it, so we're just refreshing today. So first of all, this table classifies the rocks into two different categories first. There's some of them that have sediments, and then there are some that have no sediments. So if you see no texture, then you're going to end up with just crystalline carbonate. That's just the mineral calcite, right? There's no sediments in it. And the original sediments were bound together during a deposition, like if it's all very plastic sort of, there's a bunch of shells, and that's what's holding it together more than the calcite. Then you've got bound stone. And this is just, as the grains decrease, you end up with mudstone over here. So I know that we saw some of these when we went to Canyon Lake Gorge. Do you remember? I know that we saw packstone, waxstone, and mudstone when you were there. And you probably have some really cool pictures of those things. Because I know we didn't pick up any samples, because we were asked not to. Oh, this is terrible. All right. So limestone forms, and when limestone forms, all of these reactions are reversible according to what the circumstances are, what the temperature, the pH, the concentrations. These reactions go back and forth. So we're going to start with rain. So first, the rain falls through the air, carbon dioxide mixes with the water, and you end up with carbonic acid. In 7th grade, we talk about that quite a bit, don't we? 7th grade science teachers. With the acid rain. Okay, this is part of what we talk about with weathering, in the chemical weathering process, and how that karst topography is formed. Then you take the carbonic acid, and that becomes the bicarbonate ion, and then anyway, so it all happens, and then you get the carbon dioxide in the water plus the calcium carbonate, is that the calcium carbonate in the rock then deteriorates into the calcium in the rest of this. So all that is a complicated process that just says, starts with the rain, mixes with the carbon dioxide, makes it slightly acidic, and it goes through the soil. The calcium carbonate can form in those oceanic environments, and it forms around the sediments or bigger sediments there. Then we go back to that chart where we had the different types of rocks. So remember whenever we did what was the girl's name that came and talked about the karst topography last year? She did that really cool presentation just about karst. And she said that all limestone is or will be karst. That it starts out solid, and as this acidic water comes through, then we end up with dissolution, and we get karst topography that ends up holding the water and channeling the water, and that's what our aquifers are created from. So when we went through Canyon Lake, we went through, we saw dinosaur tracks when we started, and then we stepped down a couple of layers. Remember the rock layers, we stepped down from the spillway, we went down a little bit. And what did we find down there? What were some of the things that we found down after that first step down?
All the little things.
The little shells, what were those little shells? What did they
Chinese
look like? What did these little shells look like?
They look like
They were little disc shaped.
They were on, they were on other little pieces, like, they weren't just by themselves, they were attached to, some were attached to rocks or something.
Okay.
Millions of
Yeah.
There's a
So
ton.
one of these species that we saw, one of those fossils that we saw there, do you remember you talked about corbula? Okay, this corbula is a teeny tiny little bivalve, and that, it wasn't the disc-shaped fossil that we found. This was the one that looked like rice. Do you remember the one that looked like rice? Okay, this rice-shaped fossil that we found was often like it all clumped together, like the sticky rice that we put have in our sushi. So this rice-shaped fossil is actually a teeny tiny bivalve. It has two shells together. And this bivalve is, it's called an index fossil. What do you think an index fossil means?
what, it was only around for a certain time, so they can tell like what era it was in? Or when it was,
Yeah.
what time it was found, what time periods?
Okay, you're on the right track. It doesn't mean that it was only existent in that time period. What it does mean is that it identifies a certain rock layer. So if you see that index fossil in that rock layer, when we stepped down past the spillway, we saw this corbula. We didn't see corbula anywhere else as we stepped down in time, or stepped back in time as we went down the rock layers. That corbula is called an index fossil because it identifies the bottom section of the Glen Rose. It's only present here in the bottom of the Glen Rose rock sections. So whenever you're walking and you're hiking in Central Texas and you find the corbula, you can impress your friends and say, this is the lower Glen Rose limestone. It's identified by the index fossil corbula, which is a small bivalve.
Are you speaking French?
Talking about it. Yes, just like our voice on it. So the fossils we had alluded to earlier, the type of fossils that are present tell you about the environment that you find them in. So we found that corbula, and this is just a picture of a figure in one of my old paleontology books. And so all this shows is different organisms and the environments that you would find them in, the range of environments that you would find them in. So deep environments, which are between 30,000 and 60,000 feet, you would find these organisms. If you're a sloped environment like a continental shelf, going into, getting deeper, you would find these. Right here, this is the shallow environment that you would find here. This is the shallow sea mostly that we observe. And then here's more energy-rich environments in the intertidal and supertidal, and the freshwater and terrestrial. So notice there's very few terrestrial organisms that you would find as fossils. It's mostly oceanic or saltwater. So the ones that we observed at Canyon Lake were the blue-green algae. Those formed in very shallow areas. The green algae, we looked at foraminifera. We looked at calcareous worm tubes. You remember the worm tubes we saw with like tubes, huh? Echinoderms, those are the sand dollars, that kind of thing. Pelecypods and gastropods. We found a lot of gastropods. And if you look back at the book that we received, the little spiral bound little book, I think I've got a copy of it. If you look back at that book, it gives some great pictures and explanations of what the fossils are that we saw. This book right here is great. Pull that out, and when you're talking about the different rock types that you teach in 6th grade, you can travel back to the back, and you can show pictures of the fossils. You can show pictures of the sedimentary rocks and the types of stratigraphy and how they lay on top of each other. And then in the back here, there's another little thing that gives the fossil types and pictures of them, so you kind of know what you're looking at. Okay? But this kind of tells you what to look for, or what kind of environment to look for whenever you find certain fossils. And if you find one fossil, you might have a broad range of what that environment might be. But with a combination of 5 or 6 different fossils can kind of narrow down so you can predict what the environment was and how they formed. Okay, before we get going on the stratigraphy and refresh ourselves about that, let's take a bathroom break, get that blood moving, get some okay? We will be back at 9.
Hold on.
30.
Yes, a couple of announcements. For those of you who are new, when we go on these field trips, we buy stuff for you to teach with. And when we went to the Heritage Museum, I gave each of the teachers about $50 and they could choose any of the materials that they liked. We did the same thing when we went to Natural Bridge Cavern. So that was the field trip to the gorge at Canyon Lake that Laura's talking about, and right around